All right, so let's finally put all of this together. This is what you should be able to do by now. And this is going to become important because you're going to have to do this for the rest of the year. We're going to be looking at reactions that happen, and we're going to have to figure out what products are made, and you're going to have to write the formula, and it should be done automatically. So you've got to get good at this. Here are some flowcharts that we've seen already, but it'll walk you through the steps. So if you do feel like you're a little confused or you need some more help with this, go through each of these flowcharts step by step so you get the hang of the process and what you should be thinking of. Be conscious of what it says in the flowchart as you're going through the process. And you'll catch on, and pretty soon you won't have to look at the flowchart anymore. But the first thing we're going to do is talk about examples 1 and 2. And the reason I want to talk about examples 1 and 2 together is because they're really similar. They both have copper and they both have oxygen bonding together. But the difference here is that copper makes 2 different charges. So that's something that we have to focus on. So if we're writing the formulas, the first step is write the symbols of the cation, anion. We already have that. We know what the cation is and its charge. We know what the anion and its charge. If you see like examples 3 and 4, that's the first thing we have to do. We're going to use the name to figure out what the cation and the anion is, and we're going to have to write the symbol and the charge. But for here, it's done. Then we then we compare the charges. So step 1 and 2 are done. Compare the charges. Are they the same or are they different? So in the first example, they're different. If they're different, crisscross them. Write them as subscripts. And then we have to think about, are we writing a subscript after polyatomic? Well, there's no polyatomics here, so we don't have to worry about that. So let's just crisscross them. The 2 goes here, the 1 goes there. We write Cu2O, imaginary 1. You don't have to put that. The next one, Cu plus 2O negative 2, those charges, when we compare them, they're the same. It's a 1-to-1 ratio. We're done. We just write CuO. Done. So we got 2 different formulas because we had 2 different charges. Now I wrote you a nice little note, copper makes more than 1 charge. But if I didn't give you that note, you could obviously figure it out because you see 2 examples back to back with copper making 2 different charges. So you cannot write copper oxide and think you're correct because you would be writing copper oxide for both. And they're not exactly the same. Yes, they have copper and oxygen in them, but they're different. And if you look at the periodic table, if I didn't give you 2 examples back to back, you would have to just take a peek at the periodic table and look to see if copper is one of those atoms that makes more than 1 charge. And it is, +1 + 2. That means you have to use Roman numerals. The Roman numeral is the charge, not how many are in the formula. You don't put a 2 there. It's not telling you how many are in the formula, it's telling you what the charge is, which is a +1. In this case, there's only 1 of them in the formula, but the charge is +2. That's why we put a 2 here. It's telling you which copper is bonding with the oxygen. What's the behavior of this particular copper? It's giving away 2 electrons. This one up here is only giving away 1. All right, so when we were writing the names, we wrote the name of the metal, copper. We checked to see if the metal makes more than 1 charge. We knew it did. Multiple charges, we added Roman numerals, and then we go right back to the anion. The anion is just a single element, so we changed oxygen to oxide. If it was a polyatomic, then we would just say the name of the polyatomic, but that didn't apply yet. So let's do the next one. We got lead and lead. We also have Roman numerals. That's giving you an idea that lead can make more than 1 charge. But here's the catch. You don't have to look at the periodic table. You don't need to. Assuming you know what the lead, or the symbol for lead is, which is Pb. If you didn't know that, you'd have to look it up. And by the way, lead is over here, just so you get used to that. So Pb, Pb, this lead is making a +4, this lead's making a +2, and then who are they bonding with? Fluorine. Yes, the ending is "ide" because that's what we do with the endings of elements on the periodic table. So this is fluorine. It's got 7 valence, so it needs to get 1. So it's going to make a -1. So put F -1, F -1. Anions are boring. They always make the same charge. So we crisscross it. Pb gets the 1. The 4 goes after the F. PbF4. This one, crisscross it because they're not the same. So we do PbF2. So again, we got 2 different formulas, 2 different compounds. Even though they have the same elements, the charges are different. Now we have aluminum hooking up with NO3 and aluminum hooking up with N. So let's go through our process here. Write the symbols of the cation, anion, check. Make a note of the charges. We've got the charges. Compare the charges. Are they the same or different? 3 and a 1, they're different, so we got to crisscross it. So here's the deal. You're going to put the 1 after the aluminum, so we really don't need to write anything. But we're going to put a 3 after NO3. Now, NO3 is a polyatomic ion, and I want to put a 3 after the formula of a polyatomic ion. I don't care which polyatomic ion it is. If you decide you're going to put a number on the right of it, when you crisscross the charges, you have to wrap the formula for the ion in parentheses. You have to tell me that we need one oxygen bonded to one nitrogen bonded to 3 oxygens. We need that 3 times to make one aluminum happy, because one aluminum is trying to get rid of 3 electrons, and nitrate can only take 1 electron. So we need 3 of them. So you've got to put the formula for 1 in parentheses and put a 3 after it. Now, what do we call this? Well, we write the name of the metal. Notice this is not ammonium. For some reason, kids mix up aluminum and ammonium. This is just aluminum. And then check to see if the metal makes more than 1 charge. We find aluminum. It's here. There's no extra charge. It only makes a +3. So we're good. We can skip this Roman numeral business. Then we have to decide if the anion, the negative, is a single element or a polyatomic. This is a polyatomic, more than 1 atom. Nitrogen's having a little party with oxygen. So you have to remember what that's called. If this still is a mystery to you, you need to go back and practice. Maybe do the quizzes again. Maybe watch the video with the explanations of what the polyatomics are. But you need to know that that is nitrate. And the nice thing is, you don't change anything if you have a polyatomic. You just state the name of it. So once you figured out that that's nitrate, you just say nitrate. Now the next one. We got aluminum and nitrogen. We compare the charges, +3, -3. They're the same. It's a 1-to-1 ratio. We're done. It's AlN. We don't even have to write any numbers. What do we call it? Aluminum. But then we got to deal with our non-metal. So we wrote the name of the metal. We checked to see if it made more than 1 charge. It didn't. Now we're here. Decide if the anion is a single element or a polyatomic. This is a single element. It's just N. So if it's a single element, you change the ending to "ide." So this is aluminum nitride. All right, number 7. We have sodium carbonate. If you don't have the anion and the cation and the anion or the charges, you have to write them down first. You can't do this without it. So sodium, hopefully you know sodium is Na. What's the charge? Well, you got to look at the periodic table. There's nothing in the box, so we have to look up, +1. So sodium makes +1. Carbonate. Carbonate is not on the periodic table. Don't bother looking. You've got to remember what the formula and the charge is for carbonate. So use some sort of reference tool that you have, whether it's your notes or the periodic table that I gave you, because there's a little chart up at the top of that. But you should remember that it's CO3 with a -2 charge. These polyatomics, you need to know. There's carbonate, CO3 with a -2 charge. And by the way, it's capital C, capital O, because it's carbon and oxygen. Sometimes kids write C with a little o, and then you're writing cobalt. That is not right. So we know what the formula is for carbonate, CO3 -2. So we've done step 1 and 2. Now we compare the charges. They're obviously different. We got a 1 and a 2. Crisscross them and write subscripts. And then we have to think about, are we writing a subscript after polyatomic? Well, the 2 is going to go after the Na. So it's Na2. Don't put the Na in parentheses. It's not a polyatomic. No parentheses for something that's not a polyatomic. Then the 1 is going to go after the carbonate. I'm not going to write a number after carbonate, so I'm not putting it in parentheses. It's only if you have more than 1 of the same polyatomic. It's only if you're going to write a number down here. But right now I'm not, so I don't have to use parentheses. All right, magnesium hydroxide. We've got to start at the beginning. What's the formula? of the cation, Mg. What charge does it make? Maybe you know off the top of your head because you remember. If not, look it up. Mg is plus 2. So Mg is given away to hydroxide. Hydroxide doesn't end in 8, but it's not a single element on the periodic table. You just have to remember this. Hydroxide, and I harped on this a little bit before, hydroxide is this guy here. It's O, and the O has come first, OH negative 1. So that's hydroxide. It's the only one that doesn't really end in 8, at least the ones that we're going to use. So it's OH negative 1. So we got our 2 ions and the charges. Now we crisscross them because they're not the same. So we're going to write Mg, and then the 1 from the hydroxide is going to go after it. So I'm not really going to write anything. The 2 is going to go after the hydroxide. Now, we write the formula for hydroxide. You want to put a 2 after it. Hydroxide's a polyatomic. So you have to put the formula in parentheses. Then put the 2. I know there's no little number there. Like this had a little 3, this had a 3. If there's no number, it doesn't matter. It's still a polyatomic. It still qualifies. Because if you don't write parentheses, you end up doing this. And the 2 only goes to the H. It doesn't tell you there's 2 O's. And we need 2 O's because magnesium is trying to give away 1 electron to OH and its second electron to another OH. So you need 2 of them. If you just write OH2, you're basically saying it's this, an OH and an H. That's not right. So you've got to think about what the formula is, wrap that in parentheses, then put the subscript outside. All right, let's take a look at Sn plus 4, N negative 3. So we're going to write Sn and then crisscross the charges. Here comes the 3. 4 goes after the N. That's the formula for Sn, or Sn3 and 4. What's it called? Tin is bonding to nitrogen, plain old nitrogen, so I write nitride. Remember, it's a single element on the periodic table, so I change the ending to I. Don't write nitrate there. It's not N having a party. Now, I wrote a note to you. Tin makes more than 1 charge. If I didn't put that there, you would have to look up tin, and here's tin, makes a 2 and a 4. So, how do you differentiate which is which? You look at the charge on this particular ion, which happens to be a plus 4. So what's a Roman numeral for 4? IV. The one right below it, we still have tin, but now it's making a plus 2. It's still nitride, which is just nitrogen, doing the same thing as it did up here. Crisscross them because they're not the same. We get SN3 and 2. So 2 entirely different formulas because tin makes 2 different charges. All right, I'm going to stop this video here. Why don't you try the rest and then come back and watch the second video. And I'll just quickly go over the answers.